thinking of powering your vehicle or equipment with natural gas, one of the first questions that pops up is, well, what is natural gas exactly? It's a good question. A lot of us use natural gas in our homes for heating and for cooking, but we don't give it much thought. So what is it? And more importantly, how is it different from gasoline or diesel fuel? Well, to start, in many ways, it's not a lot different. It's a fossil fuel. It's usually found with other hydrocarbon fuels in petroleum deposits and coal beds, and more recently, in shale deposits. And there's an abundant supply of natural gas in North America and around the world. Once found, it's processed, and what you're left with makes a great vehicle fuel. Natural gas, or CH4, is the simplest hydrocarbon, composed of one carbon and 4 hydrogen atoms. It's odorless, colorless, non-corrosive, and non-toxic. And it's lighter than air, so if it's spilled, it dissipates quickly, which enhances its safety. Natural gas fuel provides an excellent way to reduce emissions. Natural gas-powered trucks have fewer NOx and PM emissions than diesel trucks, and up to 25% fewer greenhouse gas emissions, and that's without complex emission control equipment. Altogether, natural gas is a clean, safe, and viable form of energy. As a vehicle fuel, it can be stored as compressed gas called CNG or in a liquefied form called LNG. But in either form, natural gas is a safe fuel. It's non-toxic and evaporates quickly. It's lighter than air, so it rises and doesn't accumulate in low places. It has a very high ignition temperature of approximately 1100 degrees Fahrenheit or 600 degrees Celsius, so it is not easily ignited. And it's also odorless. So for CNG, a detection fragrance is added. CNG stands for compressed natural gas. Basically, if you take natural gas and compress it to 1% of its volume, you've got CNG, compressed natural gas. CNG is stored in cylindrical tanks on board the vehicle. As the tanks are filled, the gas is compressed. Typically, CNG fueling stations will fill the vehicle tanks to a service pressure of approximately 3,600 pounds per square inch, or PSI. The CNG fuel system then regulates the pressure down to about 100 PSI at the engine.
Operators don't do the filling, but our service people actually had some training to do that. It's a very simple procedure. It's actually just like the old procedure of sticking a nozzle into the tank. This one, you plug it in, you lock it down, and automatically does the fueling for you. Once the bus reaches a point where it's filled, the light comes off and says your bus is fueled at 3,600 PSI, and that's all you have to do. Disconnect the safety valve, and down it goes. Very simple procedure, nothing to worry about. A lot of people have concerns about how unsafe it could be, but it's not.
With today's prices, natural gas often costs up to 50% less than diesel and emits fewer emissions, a compelling reason for many fleets to change to natural gas power.
Waste Management has been using natural gas trucks since the mid-1990s. We started out with CNG in Palm Desert, California. Most of our fleet grew in California because of the requirements for lower emissions, energy efficiency, and one of the things that we found with the increasing costs of diesel is that natural gas is much less expensive to operate. Natural gas is one of the least expensive energy sources available in North America. It's readily abundant, and there's lots of ways for us to produce it, even internally in our own landfills.
Waste Management also found that drivers appreciated natural gas power for their vehicles.
After about a week or two of driving them, they realized how much better the natural gas engines were. They were no longer smelling the diesel fumes. The engines were quieter. They didn't have to wear earplugs while they're operating the trucks. They could actually listen to the radio, and if they had a passenger with them, you could actually have a conversation without shouting. So it was quite a positive change for our drivers.
CNG vehicles are refueled at natural gas fueling stations. CNG fuel stations can be designed to meet fleet requirements, with the major difference being the vehicle fill time. There are also a number of natural gas fueling stations around the country, and about half are open to the public. let's talk about LNG, or liquefied natural gas. Liquefied natural gas, LNG, is simply natural gas that has been condensed into a liquid by cooling it to negative 260 degrees Fahrenheit, or negative 162 degrees Celsius. Now that's cold. Because it has to be kept at such cold temperatures, LNG is stored on the vehicle in double-walled, vacuum-insulated stainless steel tanks. Since the fuel is stored as a liquid, it takes up less space than a CNG system, so more energy can be stored on board the vehicle.
The reason that there's two grades of natural gas, CNG and LNG, in the marketplace is because there's a wide variety of vehicle operations. CNG is ideally suited for light-duty, medium-duty vehicles, some heavy-duty application, but the big rig trucks are ideally suited for LNG because LNG is a denser energy storage method, so we can get a lot more fuel on board with LNG than CNG. So you've got weight savings, you've got some cost savings, and you're going to get greater range out of an LNG vehicle.
So, LNG fuel systems can work well for heavy-duty vehicles that require more fuel for a longer operating range. And there are two major types of LNG fuel.
We're at the Port of Long Beach LNG station. This station is unique because it offers two grades of LNG. We offer unsaturated LNG, which we call blue LNG. This is very cold LNG. And then we offer saturated LNG. We call it green LNG to make this simple. And the reason why there's two grades of LNG is because there are two different engine technologies. Each technology has its own fuel requirements, so we offer fuel that is optimized for each technology for the drivers. Now, the only difference between blue LNG and green LNG is simply the temperature of the LNG. So saturated LNG is warmed up a little bit to create vapor pressure in the tank that delivers the fuel to the engine.
To maintain cold temperature and keep tank pressure within operating range, there are special considerations to handling LNG as a vehicle fuel.
Natural gas, whether it's CNG or LNG, is a very safe fuel, but it's a different fueling experience. So with drivers, we want to make sure the driver is trained and comfortable in fueling their truck with LNG. So what does that mean? That means that we train the driver on safe fueling practices so that they know how to operate the station. Now, of course, the equipment is different because you're pumping LNG versus diesel. But for a driver, and this is what we strive for, we want to make the fueling experience simple and quick so the driver gets in and out and back on the road.
DGE stands for diesel gallon equivalent, and DLE stands for diesel liter equivalent. These refer to the amount of natural gas that it takes to equal the energy content of 1 gallon or liter of diesel fuel. Both CNG and LNG have a lower energy content than diesel fuel for a given storage volume. To account for the different energy density between natural gas and diesel fuel, DGE and DLE are ways of comparing equivalent quantities of fuel based on their energy content. A good rule of thumb in terms of tank sizing is that 1 DGE or DLE of compressed natural gas requires approximately 4 times as much storage volume as 1 gallon or liter of diesel fuel. And 1 DGE or DLE of liquefied natural gas requires approximately twice the storage volume as 1 gallon or liter of diesel fuel. So, the amount of fuel required versus vehicle space available for the fuel tanks is an important consideration when designing the fuel system for the vehicle. In addition to the natural gas found underground, there's also another source of natural gas called biogas. When organic material decomposes, it creates methane gas, which can be used as a natural gas substitute. Sources of biogas include gases from animal waste, sewage, landfills, or crop waste. Technology is commercially available to remove the contaminants present in the biogas through processing to produce high-purity natural gas suitable for vehicles. Biogas that has been purified to pipeline natural gas quality is called biomethane. It's also referred to as renewable natural gas, or RNG. As a fuel, biomethane, or RNG, offers a number of environmental benefits. When biomethane is used as a fuel rather than being released into the atmosphere, greenhouse gas emissions into the atmosphere are reduced. For example, using renewable biomethane to fuel trucks reduces greenhouse gases by up to 90% compared to diesel fuel. So what's different about a Cummins Westport natural gas engine as compared to a diesel engine? Well, to answer that, let's start by looking at what's the same. For instance, if you look at the ISL-G engine compared to the Cummins ISL-9 diesel engine, you'll find that 80% of the components are the same. In fact, both engines are manufactured in the same Cummins engine plant in Rocky Mount, North Carolina. The ISL-G and the ISL-9 share critical components including block, crankshaft, main bearing, piston rods, and the EGR system. And since it's a factory-built dedicated natural gas engine, it benefits from the same engineering and design processes as all Cummins products. So the ISL-G delivers similar industry-leading durability, reliability, and life to overhaul as its diesel counterpart. And the horsepower ratings and maintenance intervals are also similar for both engines. Yet, there are also some important differences. First, the ISL-G utilizes spark ignition, where a spark plug ignites the fuel, as compared to compression ignition on a diesel engine. A spark plug is required because unlike diesel fuel, natural gas will not ignite with compression. And where the diesel engine has a 4-valve cylinder head, a 2-valve cylinder head is used on the ISL-G. That enables the optimum positioning of the spark plug. The piston for the ISL-G features a piston bowl designed for natural gas operation to both reduce compression and optimize combustion for optimum power density. And rather than using fuel injectors, the fuel system incorporates an integrated fuel module that mixes fuel and EGR with throttle-controlled intake air. Altogether, the ISL-G features combustion technology known as stoichiometric cooled exhaust gas recirculation, or SEGR combustion. SEGR combustion is cooled EGR in combination with stoichiometric combustion, which is the ideal combustion process in which fuel and oxygen are completely consumed. The result is lower emissions, improved power density, and better fuel economy. In fact, as compared to previous lean burn engines, ISL-G torque at idle improved by over 30%. Also, SEGR combustion creates an oxygen-free exhaust that enables the use of 3-way catalysts. This is different from modern diesel engines that utilize an active after-treatment system that includes a diesel particulate filter and selective catalytic reduction. Let's take a closer look at the ISL-G.
Hello, my name is Christopher. I'm with Cummins Westport. Today we're going to talk about the daily maintenance checks for the ISL-G engine, our 8.9 liter natural gas engine. Today this is in a truck application. On the ISL-G, the maintenance intervals are pretty simple from oil on up through all the components. The engine oil is every 500 hours. It is a natural gas specific oil for the ISL-G. The fuel filter right here is changed every 1,000 hours or second oil change interval. Also on this engine, the maintenance event on the spark plugs near the top of the engine here is every 1,500 hours or third oil change interval. The overhead valve set, the initial one is done at 1,000 hours, and from there on it's every 2,000 hours for an overhead. We are now on the exhaust side of the ISL-G engine. Talk to you about a couple of the items on this side of the engine. First is the coolant. The coolant is one of the items we want to check the level on a daily basis. The quality is checked at each oil drain at 500 hours, and then the coolant is changed every 2,000 hours The air system is critical to keep the engine clean and keep fresh air into the engine. You can see that there's a variety of clamps and pipes that we want to make sure are tight on a daily basis. Also, you have a restriction gauge in the air filter housing itself to let us know when the filter is becoming plugged. One other item over here, the oil filter. The oil filter is changed at the normal maintenance events with the engine oil at 500 hours. A couple other components on this engine that we want to point out. The engine has a wastegated turbocharger along with an EGR cooler that sits right behind the turbocharger, which is common with the other diesel counterparts of this engine. For more information, please use QuickServe Online for updates to any of these maintenance intervals.
Why do people choose natural gas power for their vehicles and equipment? There are a number of reasons. Essentially, they're quiet, clean, powerful, and simple. A key reason for many customers is emissions reductions. Natural gas is, quite simply, a clean burning fuel that emits fewer emissions. It meets North American and Euro emission standards with simpler technology than required for diesel engines.
Generally, communities demand natural gas trucks to service their communities. It's something that municipalities are demanding. Everybody wants clean air. Everybody wants vehicles that are not polluting.
Cummins Westport engines are very quiet, 9 decibels quieter at idle than diesels. This is because natural gas engines are spark ignited, and this results in a noticeably quieter engine.
Natural gas runs a lot quieter than a diesel. In comparison, nowadays from an 8.3 or an ISL to a Series 50 diesel, it's totally night and day.
Initially, our first customer response to our natural gas trucks was that they were not hearing our trucks pick up the trash. The engines were so quiet that they'd call in and complain that we weren't picking up the trash when we actually had already serviced them. So that kind of plays testament to the unique quietness of the natural gas engine.
Today's natural gas engines also offer optimum performance. Horsepower and torque are virtually identical to that of a comparable diesel engine. In fact, today, Cummins Westport natural gas engines are operating efficiently in a wide range of equipment and applications. The fuel system is different in a natural gas-powered vehicle than what you may be used to with a diesel or gasoline-powered vehicle. It starts with the fuel tanks. Natural gas fuel tanks are made to carry either CNG fuel or LNG fuel. Both of these natural gas fuels can offer advantages, and choosing CNG or LNG usually depends on fuel availability in your areas of operation, space considerations for your vehicle, and the range requirements for your application. Typically, the truck or bus manufacturer will supply the vehicle fuel storage and delivery systems. Cummins Westport, however, does provide guidelines for the fuel system to ensure optimal engine performance. In general, a natural gas system, whether it uses CNG or LNG fuel, will consist of the fuel tank, fuel lines made of high-quality stainless steel tubing, tank pressure gauges, a manual shutoff valve that is clearly marked to shut off the fuel supply to the engine, and low-pressure fuel filter for service and emergency use, a regulator to control the fuel pressure to the engine, an electronic shutoff valve that is activated when the ignition key is in the on position, fuel filters, and a low-pressure indicator lamp on the instrument panel of the vehicle. A CNG fuel system will utilize CNG that is stored in fuel tanks under pressures of up to 3,600 psi at 70 degrees Fahrenheit or 21 degrees Celsius. Typically, CNG tanks have a capacity of 15 to 25 DGE per tank, and often there will be 3 or 4 tanks packaged as a fuel system on a vehicle. For extra capacity, there are also larger tanks up to 40 DGE that can be mounted on the vehicle frame.
Compressed natural gas is stored on the vehicle at 3,600 psi. We regulate it down to about 115 psi for the Cummins engine inlet. Vehicle configurations vary depending on the chassis layout, from a refuse truck with cylinders mounted on top, which is generally a 60 or 75 diesel gallon equivalent configuration, to a trash truck that might be a roll-off configuration like we're standing next to today. That would have tanks generally mounted on the side of the vehicle, and that can range anywhere from 40 DGE up to 100 DGE depending on the configuration.
Mounting multiple tanks on the vehicle can increase the fuel storage to over 150 DGE for longer range. The CNG storage tanks can be mounted either vertically or horizontally, depending upon the application.
It's not just so much mounting the tanks, it's integrating the tank with a structure to protect the tank that's designed to integrate with the vehicle and maximize the space, the footprint. You want to maximize fuel capacity within a given footprint. So we have a superstructure that surrounds the tank that generally is designed to protect the tank, integrate with the vehicle, and then we also protect the tank from UV or road damage with aluminum or steel shielding. In addition to that, we have what we call a fuel management module that basically is the user interface. So that's where the operator of the vehicle will fuel the vehill. They'll have an NGV1 fuel receptacle typically. They'll have a quarter-turn shutoff valve to allow service of the engine. It'll have a coalescing filter, high-pressure coalescing filter.
LNG fuel tanks store natural gas in a liquefied state. LNG is cryogenic and is stored in double-walled, vacuum-insulated stainless steel tanks.
In general, the way the LNG system works is you've got cryogenic, generally minus 200 degree Fahrenheit liquid in a big thermos on the side of the vehicle, and in a general tank size is about 150 gallon gross, which equates to about 80 gallons diesel equivalent, give or take 5 gallons. And so that liquid is extracted from the tank, through the demand of the engine. It's vaporized in a heat exchanger, which is basically a coolant. Engine coolant runs through the heat exchanger around the tubing that holds the cryogenic fluid. It vaporizes, and by the time it gets to the engine doesn't know the difference whether it's stored as LNG or stored as CNG on the vehicle. So the bottom line is the engine is exactly the same. The gas gets to the engine at about 110 to 115 psi.
A typical LNG tank will have a capacity of 60 or 75 DGE, and usually there will be one or two of these tanks mounted on the vehicle. LNG requires about half the storage space as CNG for an equivalent amount of energy. Unique to the LNG system is that it incorporates a vaporizer to warm the LNG to a gaseous state for delivery to the engine. When the engine is not running, the LNG fuel in the tank will slowly return to the gaseous form as the fuel warms, increasing the fuel pressure in the tank.
On an LNG tank on the vehicle, as opposed to CNG, it's stored at 3,600 psi. Your LNG tank is going to be stored anywhere from 100 psi to 230 psi. From the tank, you have high-pressure stainless steel tubing, and generally that's going to be stainless steel hard tubing. In some cases, that might be a flexible Teflon-braided stainless steel covered hose, or some other form of flexible tubing that's cryogenic rated for at least minus 300 degrees Fahrenheit. From the tank, that tube will go to the heat exchanger, where the liquid is then converted into gas. Downstream from the heat exchanger, we have a lock-off solenoid, which basically is like a fuel pump switch, where it basically shuts fuel flow on and off depending on the key switch. After the lock-off solenoid, we have what we call an overpressure regulator. And what the overpressure regulator does is it keeps the fuel from getting over 150 psi, because the Cummins engine wants to see pressure between 110 psi and 150 psi. Anything more than 150, and you'll have a check engine light for overpressure as opposed to low pressure that we talked about earlier. So after the overpressure regulator, we have a flexible hose that'll take the fuel from there to the low pressure filter, which is generally installed either behind the cab or on the engine. And again, that's just basically a spin-on fleet guard filter that's separating any impurities before it gets to the engine. On every LNG vehicle, it's required by standard and code that you have a methane detection system.
In general, if the vehicle is used on a regular basis, pressure in the LNG tanks will be managed by the system. However, if the vehicle is parked for an extended period of time, the pressure in the tank may increase to a level that will cause the tank to vent gaseous fuel and reduce tank pressure. So steps should be taken to minimize this. You can find out more from your OEM or fuel supplier. Unlike CNG, there is no odor added to LNG system. And that's why, for safety, a methane detection system is installed on the vehicle to detect any possible fuel leaks. Fueling with natural gas is different than fueling with diesel and gasoline. There are differences in the stations, as well as the steps involved in refueling the vehicle. There are refueling stations open to the public in many cities. In addition, there are many refueling stations that are owned by businesses, municipalities, or school districts. There are a number of companies that design and construct fuel stations for private fleets. A CNG fuel station receives natural gas via a pipeline and compresses the gas on site from the relatively low pipeline pressure into tanks at 3,600 psi. There are several kinds of fueling stations available for CNG. Fast fill stations have high compression capacity and can provide refueling in about 5 to 10 minutes. As the tanks are filled at a fast fill station, the gas heats up, so typically, fast fill stations will fill to a service pressure slightly above 3,600 psi. As the gas cools, the gas pressure will decrease. So the end result is that the tanks will be filled up to about 3,600 psi. Time or slow fill stations are typically used when vehicles are parked between shifts and can take several hours to refuel. But time fill stations are less costly to build and operate and are often the choice for fleets that are not active overnight.
At this facility, we have what's called a time fill CNG fueling station. Basically, you take gas out of the pipeline, compress it to 3,600 psi, and fuel the entire fleet simultaneously through a cascade filling system. There's very little labor involved. You don't have someone waiting in line to fuel their truck up, like what's common at our diesel fleets, where we have drivers waiting in line for other drivers to fuel, and it can take upwards of 15 minutes to fuel one truck.
Time fill and fast fill stations are temperature compensated, which means the final fill pressure depends on the ambient air temperature. When refueling on a day colder than 70 degrees Fahrenheit or 21 degrees Celsius, the final settled fill pressure will be less than 3,600 psi. When refueling on a day warmer than 70 degrees Fahrenheit or 21 degrees Celsius, the final settled fill pressure should be slightly higher than 3,600 psi.
So if a vehicle is going to be slow filled, we tend to be concerned less with the configuration of the plumbing or the valving configuration than if it's going to be fast filled. If it's going to be fast filled, we make an emphasis on making the most efficient use of large diameter tubing. We may increase the receptacle to what we call a CL5000, which is also considered or called a transit fill in the industry. And that's capable of flowing up to 5,000 standard cubic feet per minute. But it's not just the fill that is going to maximize or minimize your fill time, maximize the performance. It's also the tubing behind it, the configuration of the tubing, and the configuration of your tank. So we work hard on a daily basis to maximize that and minimize the effect of operators' time to fill the vehicle.
In addition, there are other potential advantages of using time fill for your vehicles.
When you time fill a vehicle, your electricity costs are cheaper because you can fill it at night. You don't have an operator manning the vehicle while it's filling, typically. There's a lot of advantages of time fill. It's also better for your station as far as maintenance and wear and tear on your compressor. But before you order, whatever configuration of vehicles you're going to order, it's absolutely one of the key components to consider is what is your fueling strategy, and get involved with somebody like Agility to help, get some guidance on, what the appropriate way to set up your fleet is.
When thinking about natural gas for your fleet, An important consideration is the station design and fueling strategy.
We have had a lot of people come and visit us from different countries, Mexico, South America, Canada. Lots of people that are just going into the business of CNG. And they're reluctant to get started because they actually don't have a very good idea and a solid idea how to start. So they come here and they look at how did we start this, from the installation of a CNG fuel station to designing a shop. People don't have those ideas in concrete, and so when they're designing a new plan, and when they want to get started, they actually need to get with people that have experience that actually make it work so that they can get better ideas to what they need. Because it can depend on if you run 50 buses or if you run 500 buses, it makes a big difference on your fuel station and the amount of money that you're going to spend.
There's a lot of questions about LNG in the market. People are familiar with CNG because it's been in the market for a while. LNG is kind of the new kid on the block. It's not really new. It's been around for a long time, but it's now starting to penetrate the market. The reason that there's two grades of natural gas, CNG and LNG, in the marketplace is because there's a wide variety of vehicle operations. CNG is ideally suited for light-duty, medium-duty vehicles, some heavy-duty application, but the big rig trucks are ideally suited for LNG because LNG is a denser energy storage method, so we can get a lot more fuel on board with LNG than CNG. So you've got weight savings, you've got some cost savings, and you're going to get greater range out of an LNG vehicle.
LNG is typically produced in a liquefaction plant and delivered via truck to refueling stations and stored in tanks. So it can be offered in locations where the natural gas pipeline is not available. Refueling time is similar to diesel or gasoline fuel. The LNG fuel tank is designed to be top-filled through a single fill hose with no vent return. This is accomplished by spraying subcooled LNG into the vapor space of the tank. The cold liquid condenses the vapor and creates space for itself inside of the tank, eliminating the need to vent product.
An LNG station actually works very similar to a diesel station. So you'll see at our station here, we have above ground fuel storage tanks, just like there would be storage tanks at a gasoline or diesel station. We have pumps, we have dispensers, so at the component level, there are similarities. We're at the Port of Long Beach LNG station. This is the world's largest retail LNG station, and we built the station here in the ports of LA and Long Beach as part of the port's efforts to clean the air. It's a very busy station. In fact, there's well over 1,000 LNG trucks that are operating here in Southern California. Many of them we see everyday fuel here. This station is unique because it offers two grades of LNG. We offer unsaturated LNG, which we call blue LNG. This is very cold LNG. And then we offer saturated LNG. We call it green LNG to make this simple. And the reason why there's two grades of LNG is because there are two different engine technologies. Each technology has its own fuel requirements, so we offer fuel that is optimized for each technology for the drivers. The only difference between blue LNG and green LNG is simply the temperature of the LNG. So saturated LNG is warmed up a little bit to create vapor pressure in the tank that delivers the fuel to the engine.
So, what's it like to refuel with LNG fuel? Let's take a look.
Natural gas, whether it's CNG or LNG, is a very safe fuel, but it's a different fueling experience. So with drivers, we want to make sure the driver is trained and comfortable in fueling their truck with LNG. So what does that mean? That means that we train the driver on safe fueling practices so that they know how to operate the station. We also make sure that they have the proper protective gear in safe fueling so that when they're done with their training, they can go anywhere and fuel their vehicle with confidence that they're doing it properly and safety.
The LNG tanks used with Cummins Westport engines require some pressure in the LNG fuel tank for effective operation. LNG fuel that will enable the required fuel pressure at the engine inlet is called saturated LNG. Consult your natural gas fuel provider to ensure the LNG meets Cummins Westport specifications. There are some stations that offer both CNG and LNG. They store LNG, which can be vaporized into CNG before fueling. As with any engine, regular maintenance and care is important to ensure optimal performance for your natural gas engine.
At the beginning, it was a big experience because we were encountering with new technology. We needed training. We felt that working on diesel engines all of our lives and jumping to a new alternative fuel, we were going to encounter a lot of resistance from the mechanics, from the training department. But it turned out that most of the OEMs, New Flyer and Navi, actually helped in and jumped in with the training department. They came in and helped us out. Cummins engines came in and trained all our mechanics, and the mechanics felt very comfortable working with them. There is actually a lot more, it's a lot easier for them to work now on CNG engines.
The design of the ISLG is based on its diesel counterpart, the Cummins ISL9.
Cummins Westport Engineering changes the power cylinder, the fuel system, and the ignition system, but really retains the vast majority of the components that were developed and validated for the ISL9 diesel application. By doing so, we retain all of the inherent robustness, durability, and reliability that Cummins validated and has demonstrated over many years with the ISL9 in a variety of commercial vehicle applications. Cummins Westport follows all of the same engine design, validation, and demonstration protocols that Cummins does for its diesel engine platforms. As a result of that, the engine is very thoroughly tested, and all aspects of its performance, reliability, and durability are validated and demonstrated before launch. In fact, it's a requirement before we can sell engines that they must go through standard validation tests, which is not always the case with conversion systems. Also, by virtue of having factory available natural gas engines, we inherently work directly with the vehicle manufacturers and therefore go through all of their similar testing and robustness protocols to validate the engine and the vehicle together as a system prior to selling the vehicle to an end user. Really, it's a risk mitigation strategy for end users. They can be confident that they're buying a product that's been validated by Cummins Westport as the engine manufacturer, properly integrated by the vehicle manufacturers who do this for a living, and there's widespread availability of parts, service, and warranty support through the distributor and dealer networks nationwide.
While the maintenance intervals for the ISLG are similar to the ISL9 diesel, there are a few important maintenance points to keep in mind for Cummins Westport natural gas engines.
The vast majority of the maintenance items in the ISLG maintenance schedule are identical to those prescribed by Cummins for the ISL9 diesel engine. There are, however, a few key differences which are very important to ensure robust operation of the ISLG engine. Most notably, the ISLG engine has spark plugs, whereas of course a diesel engine does not. The spark plugs are required to be replaced every 1,500 hours, and it is important to maintain that maintenance schedule in order to ensure the continued operation of the other components in the ignition system, such as the ignition coils and the ignition control module.
A key maintenance factor for both natural gas and diesel engines is the oil drain interval, which is duty cycle dependent. So consult the owner's manual for details. Cummins Westport natural gas engines require special natural gas engine oil that is available from most major oil suppliers. The engine oil specification CES 20074 is important because natural gas engine oil has different properties than diesel engine oil. A sulfated ash limit of 0.6% has been placed on all engine lubricating oil recommended for use in Cummins Westport engines. Natural gas engines also require less detergent in the oil as there is no soot residue. Service intervals are based on hours, months, or distance determined by average vehicle speed, whichever comes first. For example, the oil drain interval is 500 hours or 6 months with the mileage determined by the vehicle application. The maximum valve check or adjust service interval is 60,000 miles or 96,000 kilometers and can't be extended. Lower average speed applications like transit and refuse will have shorter distances between intervals. Spark plug service interval maximum distance is 45,000 miles or 72,000 kilometers. based on 30 miles per hour or 50 kilometers per hour average speed, and again must be reduced for lower speed applications. Another operating tip is to check or drain the fuel filter daily to prevent water or oil from entering the engine's fuel management system.
Another key distinction with the ISLG is that due to its 2-valve per cylinder head, there is a slightly different overhead valve setting and adjustment maintenance interval required than for the ISL 9 diesel engine. Specifically for ISLG, it's critically important that the first overhead set be performed after the first 1,000 hours of engine operation. Thereafter, every 2,000 hours or every fourth oil change, the overhead on the ISLG engine needs to be monitored and adjusted if necessary.
Cummins Cal Pacific offers ISLG C-Gas Plus training for all our customers. Our training facility is located in Riverside. It's centralized in Southern California, so whether you're in San Diego, the Inland Empire, Los Angeles, or Orange counties, you can get to it easily. We offer ISLG training quarterly at a minimum, and we also do special training tailored for our customers at their site if they want us to come out, if they can get a large enough crew. If they're making a major investment in Cummins, we'll make an investment in them.
In addition to owner and service manuals, Cummins Virtual College and Classroom on-engine technician training for Cummins Westport engines is available through local Cummins distributors. The Virtual College is an online training course that can be combined with classroom on-engine training to provide technicians with all they need to know to service, diagnose, and repair Cummins Westport engines. All operation and service manuals, including fault code diagnosis and troubleshooting trees, are available in hard copy form and can be found online via a subscription to Cummins QuickServe Online, or QSOL. QuickServe Online offers the most up-to-date information. Customers can look up their engine serial number and find specific information regarding product updates, service notices, parts, maintenance, and repair procedures, and warranty. Cummins Westport also posts general service interval information online at www.cumminswestport.com. When incorporating natural gas vehicles into your fleet, there are some key items to keep in mind in terms of your operations and maintenance facility. There are a couple of things to think about. First is a safety procedure shop plan for minor and major repairs in the facility. And second are the modifications to the facility required for natural gas engine repairs. Facility changes typically include selecting an area of the shop that would be designed for natural gas repairs, adding methane detection and air handling in the event of methane leaks, and modifications to electrical and heating systems. Here are several key elements that you'll want to consider as you assess your facility. First, a methane gas detection system, which will include a backup generator to keep the detection system running in the event of a power loss. Second, an air handling system for proper ventilation, which would involve opening doors and activating ventilation fans. Third, any needed upgrades to the electrical and heating systems. And fourth, making sure all safety procedures and restrictions are observed. We'll take a look at each of these key areas. Typically, in preparing a facility to service natural gas vehicles, you'll work with someone who has experience with natural gas service requirements.
So when we're assessing the building for the first time, you'll be having to provide some information to a consultant or a specialist that would help you walk through those processes. They take a look at the layout of your shop, so a shop drawing would be handy. Any type of AutoCAD drawing would be really good. They can do an actual layout and show where trucks would be parked, what type of work would be performed in certain bays. They'd map out where your methane detection systems would be. They'd also do a calculation on how big a ventilation fan is required and how many ventilation fans might be required to do the job. And then we have automatic door openers that would actually open doors. And all of that would be indicated on the drawing, and that would be the first step.
Whenever a natural gas vehicle is being stored or serviced in an enclosed area, certain safety measures need to be followed. It is important to understand these requirements and how they will apply to the service and facility plans. You should also check with your local authorities regarding local fire and safety regulations. As a reference, the National Fire Protection Agency publishes an industry standard, NFPA 30A, for natural gas vehicle facilities. They also provide a guideline for installation and inspection of natural gas fuel systems on vehicles, NFPA 52. Both of these guidelines are available at the National Fire Protection Agency website, nfpa.org. The natural gas vehicle industry also provides some service guideline reference material. The Clean Vehicle Education Foundation has published a paper offering guidelines for facility modifications for natural gas vehicles, which is available at cleanvehicle.org. And the Canadian Natural Gas Alliance has also published guidelines. To fully understand what may be required, it makes sense to first develop a safety plan for the facility. This would involve developing safety procedures for minor repairs, where the vehicle would be in the shop for a few hours with the fuel system closely monitored, as well as developing procedures for major repairs, which would have the vehicle indoors for an extended period of time and may require defueling the vehicle.
One of the first things you have to do is do a risk analysis, get a feel for what you want to do and how you want to do it, whether you're going to be servicing LNG vehicles or CNG vehicles or both. Take a look at some of the processes you're doing. Those will all be identified in what's called a shop safety plan. So probably the best place to start would be by developing a shop safety plan. So in your shop safety plan, you'll identify the type of activities you're going to be performing. Some of the activities can be done outside of the building, and some of the activities can be done inside the building. For instance, if you're going to be removing, let's say, high pressure cylinders or liquefied natural gas tanks, your plan may say that you're going to perform those functions outside of the building. And for other functions like replacing injectors or replacing regulators or high pressure lines, then we would be doing that type of activity inside the building, or for regular servicing like brakes, transmissions, those sort of things. The second step would be looking at what you're going to do for your shop in the event that you do have a leak. And then the third part of it would be, what do you do if there is a leak or there's an event? How do you deal with it from a safety perspective or from an evacuation perspective?
Natural gas is lighter than air, and so considerations about the proper roof height and ventilation are important. Gable or open web steel joint roofs are well suited for your facility, as gas will not pocket and ventilation systems can be modified. The air handling system will circulate and evacuate the air within the shop to prevent the accumulation of methane. Also, all electrical service should be relocated to be at least 18 inches below the ceiling. The ceiling height should be sufficient so that any leaked gas can rise above potential ignition sources. A ceiling height above 20 feet is best.
I think the roof design is probably the most important element of where we're going to be positioning the equipment and how much equipment is going to be put in. The roof design, basically you're looking at how many lights you have, what type of lights are the explosion-proof lights. If they're non-explosion-proof lights, we can still work with that by cutting off the power at 10% of LEL. Also with the roof design, you'll be looking at other electrical supplies, other gas ignition sources, like open flame heaters, open and high temperature heaters are a no-no. That basically is something we have to avoid. So there may be a whole relook at the type of heating systems that you're using and the type of ventilation systems you're using. So basically anything that's open flame is something that automatically would need to be changed.
Gas detection equipment is required and a key element of the facility design. The system will be automated and linked to the facility's electrical and ventilation systems and shop doors. Typically, the methane detection system will sound an alarm at lower limits of methane to allow the system to be activated quickly and safely.
The basics of shop modifications probably start at methane detection. So primarily you'll have an alarm panel tied into a methane detection system. The methane detection system will then detect gas, and at the appropriate level, probably about 10% of the lower explosive limit of a gas leak, and that gas would be accumulating in the top part of the building. So when you're talking about the events of how everything works together in the event of a leak, a shop like this, for instance, will have an alarm panel. The alarm panel is tied into methane detection system. So the steps would be that the methane detection system would be detecting whether there was gas, stray gas in the building. If there is stray gas in the building for any reason, then the methane detection 10% below the lower explosive limit of natural gas, so this is before it becomes explosive or ignitable, would then set a series of things into play. The first thing would happen would that the vent fans would probably kick in and air would start to flow out through the ceiling. The second thing would happen is the doors would open up. We'd have selected doors that were driven by explosion-proof motors. Those motors would manually open the doors in this shop to create an airflow from the ground up through the ceiling. And the third thing is there would be a shutting off of all of the lights and all the power, or maybe even all the gas in the top 10-foot radius of the ceiling. For those shops that have explosion-proof lights and all sealed connectors in the ceilings and all approved heaters, they probably wouldn't have to do that. For this particular shop, that's the path they've taken to make their shop safe.
Another important consideration in your facility design is the location of vent stacks that can be connected to vehicles in the shop.
For CNG shops, you may have a vent stack installed in your shop to take that last bit of gas out of a tank in order to take a high pressure gas valve out of a tank. For an LNG system, you have a vent stack. You can actually have maybe vent lines coming from your vent stack on your trucks that are mechanically connected from the truck to the vent stack in the event of an overpressurization of an LNG system. And then that gas can actually vent through the same vent stack that you would normally use for CNG venting.
In addition to the facility design, many shops add a level of safety and increased technician confidence through the use of personal safety equipment.
For some shops, they have the additional measure of personal safety equipment, where each technician may be wearing a gas detector on his hip or on his person, so that basically it would pick up any type of methane detection or lack of oxygen. So this is quite common in a number of shops, especially for those shops where they're dealing with working around gas and gas leaks. They would actually have that as an additional level of protection. And in this case, the actual technician may take it upon himself to hit an emergency button and actually manually trigger all of that we talked about before.
Of course, in addition to your facility design, a shop plan will ensure that technicians are trained and certified to work on natural gas fuel system components. Remember that a key requirement for the renovation of an existing facility or the construction of a new one is to meet the proper codes. Become familiar with the codes and standards required by your municipal, state, provincial, and federal agencies. Training resources include the Natural Gas Vehicle Institute, NGVI, which provides technical training, consulting, and information on natural gas vehicles, and fueling for fleet operator and industry members in North America. The website is www.ngvi.com. For CNG certification, technicians must complete the application process and testing requirements of CSA standards. The website is www.csa-america.org.
Hello, I'm Scott Baker with Cummins Westport. I'd like to provide an overview of the Cummins Westport ISLG natural gas engine. The ISLG is a dedicated natural gas engine based on the Cummins ISL9 diesel engine platform. The ISLG is available with a range of ratings from 250 through 320 horsepower and up to 1,000 pound-feet of torque, and is commonly used in a wide variety of commercial vehicle applications. First introduced to the market in 2007, the ISLG is factory built and tested at the Rocky Mount engine plant in Rocky Mount, North Carolina, which is the same engine plant where the Cummins mid-range diesel engines are manufactured. ISLG is available and compatible with a wide range of natural gas fuels, including compressed natural gas, liquefied natural gas, and renewable natural gas or biomethane. As I mentioned, the ISLG engine is designed as a dedicated natural gas engine based on the Cummins ISL9 diesel engine platform. In fact, over 80% of the components are common between the two engines, including major elements such as the block, oil pan, flywheel housings, and major customer selectable options such as starters, alternators, and air conditioning compressors. The primary differences and distinguishing features between the ISLG and the Cummins ISL diesel engine include the natural gas fuel system on the engine, the ignition system, the turbocharger, the electronic control module, and internal components such as the power cylinder, specifically the piston bowl geometry. In terms of the main distinguishing features, let's start by taking a look at the fuel system on the ISLG engine. The function of the fuel system is to deliver precisely controlled quantities of natural gas fuel, charge air, and exhaust gas, or EGR, to the engine. Fuel is delivered to the engine at this location here. After the fuel enters the manifold, the fuel is regulated to ensure a steady fuel delivery pressure to the mixer. Fuel flows and pressures and temperatures are measured using various sensors in the fuel system. Downstream of the fuel control valve, intake air is introduced to the engine from the vehicle's charge air cooler and then passes through an electronic throttle which precisely controls airflow. Airflow, EGR, and fuel are mixed in the mixer internal to the fuel manifold, and the controlled quantity of air, EGR, and fuel are delivered to the power cylinder for combustion. Combustion in the ISLG engine is controlled by the ignition system, which consists of the ignition control module, 6 high voltage ignition coils, spark plugs, and various interconnecting components, including a wire harness and ignition coil extensions, which communicate between the ignition coils and the spark plugs, thus dispensing with the need for high voltage ignition wires or ignition leads. Therefore, there are no maintenance or replacement components in the ignition system with the exception of the spark plugs. Consult your owner's manual or your Cummins Westport representative for current information regarding the required maintenance interval for the spark plugs. The electronic control module on the ISLG engine is a derivative of the ECM family used on Cummins mid-range diesel engines. By being common with the diesel engine ECM family, the ISLG ECM is fully compatible with Cummins diagnostic and service tools, including Insight. Now let's take a look at the engine similarities and differences on the hot side or exhaust side of the engine. The majority of the components on the hot or exhaust side of the ISLG engine are identical to the components on the ISL9 diesel, including the exhaust manifold, the EGR cooler, the lube oil filter, and the thermostat housing. The primary difference between the ISLG and the ISL9 diesel engines on the hot side of the engine is the simple, proven, waste-gated turbocharger used on the ISLG, in comparison with the larger variable geometry turbocharger used on diesel engines. Since commercial introduction in 2007, the ISLG engine has become widely available in a broad range of commercial vehicle applications as a factory-installed option from vehicle manufacturers. The ISLG is available in a range of commercial bus applications, including urban transit buses, shuttle buses, school buses, and highway coaches. The ISLG is also available in a range of vocational truck applications, such as refuse collection trucks, yard tractors, and street sweepers, and is also available in over-the-road truck applications, including straight trucks and regional haul delivery tractors. Cummins Westport offers full factory warranty on the engine and also offers a comprehensive range of extended coverage options. As with all Cummins Westport engines, parts, service, and warranty support is available through your local Cummins distributor or Cummins certified dealer. With wide OEM availability, industry-leading efficiency and performance, and robust diesel-like performance, the ISLG has become the natural choice for a wide variety of commercial vehicle applications. Hi, I'm Scott Baker with Cummins Westport, and I'd like to provide an overview of the Cummins Westport ISX12G dedicated natural gas engine. The ISX12G is a spark ignition engine utilizing stoichiometric cooled exhaust gas recirculation technology in conjunction with a simple, passive, maintenance-free three-way exhaust catalyst. The ISX12G is based on the Cummins 11.9-liter ISX12 diesel engine platform and is factory built and tested at the Jamestown Engine Plant in Jamestown, New York, which is the same plant where Cummins manufactures heavy-duty diesel engines. The ISX12G is available with a broad range of performance ratings up to 400 horsepower and 1450 pound-feet of torque, and is suited for a variety of heavy-duty truck and bus applications. The ISX12G is compatible with a range of natural gas fuels, including compressed natural gas or CNG, liquefied natural gas or LNG, as well as renewable natural gas or biomethane. Visit CumminsWestport.com to review the ISX12G fuel specifications. The ISX12G shares the majority of features and options available with the Cummins ISX12 diesel engine. In fact, the majority of the components are identical between the two engines, including the cylinder block, the crankshaft, and options such as the flywheel housing and customer selectable options including starters, alternators, and air conditioning compressors. The unique features and characteristics of the ISX12G engine versus its diesel peers are the natural gas fuel system and the ignition system. Additional changes to the gas version of the engine include a 4-valve cylinder head specifically manufactured to accommodate spark plugs, a unique piston bowl optimized for natural gas combustion, and a simple, proven waste-gated turbocharger for natural gas combustion. Let's take a closer look at the fuel system and point out some of the similarities and differences between the diesel and gas engines. The ISX-12G uses a two-piece fuel conditioning system. The first stage of the ISX-12G fuel conditioning module is responsible for introducing the natural gas fuel to the engine and for low pressure regulation to ensure a steady delivery of natural gas to the second stage of the fuel manifold. Fuel is delivered to the second stage of the manifold where it is measured and metered to the fuel mixer. Exhaust gas recirculation, or EGR, is controlled by the engine-mounted EGR valve, and similarly, charge air from the vehicle charge air cooler is introduced to the engine and controlled by an electronic throttle. The quantities and flows of charge air, exhaust gas, and natural gas fuel are precisely controlled to ensure an optimal mixture of the three for natural gas combustion. Combustion in the ISX-12G engine is controlled by the ignition system, which is a unique subsystem for the natural gas engine in comparison with the diesel engine. The ignition system consists of an ignition control module, high voltage ignition coils using coil on plug technology, as well as interconnecting components including a wire harness and ignition coil extensions which connect the underside of the ignition coils to the top of the spark plugs. As you can see on this engine, the ignition coils are recessed into the valve cover to provide optimal packaging. The ISX-12G engine uses a unique electronic control module developed by Cummins Westport, but based on the same family of electronic control modules used by Cummins for its diesel engine families. By being a derivative of an existing Cummins diesel ECM platform, the ISX-12G ECM is fully compatible with all Cummins service and diagnostic tools, including Insight. The ISX-G is also available with an optional compression release brake, commonly known as a Jake brake, which is a unique feature for spark-ignited natural gas engines in the commercial vehicle marketplace. Now let's take a closer look at the hot side of the engine and review similarities and differences between the ISX-12G engine and comparable diesel engines used in heavy-duty vehicle applications. The majority of the components on the hot side of the ISX-12G engine are similar to, if not identical to, the components used on the 12-liter diesel. Identical components include the exhaust manifold and the lube oil filter. The EGR cooler is very similar between the two engines, and the primary distinguishing component on the hot side of the engine is the simple, proven wastegate actuated turbocharger used on the ISX-12G in comparison with the larger variable geometry turbocharger used on diesel engines. The ISX-12G is available in a broad range of on-highway truck and vocational applications. Visit CumminsWestport.com for a complete list of OEM availability with the ISX-12G engine. Cummins Westport offers full factory warranty support for the ISX-12G engine and also offers a broad range of extended coverage options. As with all Cummins Westport engines, parts, service, and warranty support is available through your local Cummins distributor or Cummins certified dealer. With broad OEM availability, robust diesel-like performance, and a broad range of ratings, the ISX-12G is the natural choice for a wide variety of on-highway truck applications.